Hi, in this video I'm gonna be showing you how I created a morphing ramp asset for the use in DAZ Studio with the help of Blender. Since this is a fairly long video, you might want to consider using the chapter markings below if you don't have time or social media already ruined your attention span to something below an ordinary school lesson. Seeing this primitive object, you might ask the question, why go for the effort and make your own while there is a plentitude of pre-made assets ready to be used? Just buy one and you're good. Well, yes, that could be an option, but these are not morphing, are they? So if I bought this cinder block, for instance, all I could do with it out of the box, scale it. On the other hand, there are more flexible products like this collection of primitives. But even though this features a whole lot of different shapes, it does not quite offer what I have in mind. There is that wedge, but that's only halfway. That pyramid shape comes close. Let's see what morphing options I have. I have apex out and base out. And that's it. Also, there are other issues with that model, which I show you later in this video. Not finding what I want and not willing to spend money is only half the truth. My main motivation is the adventure to create my own morphing object, and the pride if I succeed. Ready for the trip? Then jump on! First I fire up Blender, since DAZ Studio doesn't allow me creating and editing the mesh I need for this model. Unlike DAZ Studio, Blender has quite an extensive collection of primitives. You get those in the Object Mode's header menu under Add, Mesh. There I decide for the cube. This is the same cube Blender loads by default in a new and untouched installation, so if you want to play along and install Blender, you don't have to add it. This cube will be the middle of the ramp. I just have to add the two wedges to the sides. For this I change to the edit mode. This time I'm using the menu, but it also works by simply pressing the tab key. The viewport selection mode is set to vertex, therefore I see the vertices as little dots. And because my cube was selected in the object mode, its vertices are also selected now in the edit mode. I want to extrude a face of the cube, so I need to be in face selection mode. The dots disappear and I can select the face by clicking on it. Let me quickly set up the screencast keys so that you can see what keys I press in the left lower corner. So again, I select the face I want to extrude and then hit E, the command for extrusion. Blender immediately creates all new vertices and faces needed for that. We just can't see it because it's still congruent with the previously selected face. By default, Blender assumes I want to extrude along the face's normal vector. Blender shows the axis the extrusion will follow as blue line. Since the cube is still in its default position, this happens to be also the y-axis. If I now move my mouse, the extrusion will follow the blue axis. Once I'm happy with it, I just click and Blender leaves the extrusion mode. Now I have to do exactly the same on the other side of the cube. Once more, select the face by clicking on it, hit E and move out the face. But how far do I have to move to get the model symmetrical? What's the left extrusion's distance anyways? Sure, I could measure the distance and then type in the position of the left face and all that, but there is a much easier way, and that's using the grid. I ditch what I've done so far and take a look from above. Here you see that the cube size is already matching the grid size. I can switch on Snap to Grid with that little magnet-like button in the viewport's header area. Blender offers some options where to snap the transform to. You can snap to vertices, edges, faces and some other things, but I go for increment, that's the grid and also the default setting. If I now extrude, you see that it grows only in increments that happen to be the grid size. Because I shifted the face by two distinct snaps, I can do exactly the same on the other side. And now it's perfectly symmetrical. I leave the snap mode, but I'm still in face selection mode. I switch that to edge selection because I want to create the wedge now. I select the upper left face and press G to activate the Move tool. I only want to change the height position of the edge, so I restrict the motion to the Z axis by pressing Z while being in Move mode. Blender displays the blue help axis again to show me that the transformation is restricted. The edge follows only my mouse's up and down movements. To finalize my transform, I simply click once and Blender leaves the transform mode. Wanting to adjust the other side, I realized that switching off the grid was not such a good idea because now I run into the same problem like before. I can't dial up the exact position of the edge. So what shall I do now? Adjusting the grid? No, because there is a simple and clever way to get symmetry. Notice these 3 little buttons for symmetry here? I revert my last operation and set the symmetry to the y-axis. And now watch what happens if I move the edge. Perfect. Note that the center point of my symmetry is the center of the object. This leads me to some notes on mesh symmetry because there are some pitfalls I already stumbled into. Here you can adore the icosphere mesh, one of Blender's primitives. With symmetry on, I can symmetrically edit the mesh, just like you saw it previously. But if I shut off symmetrical edit and alter only one side of the mesh, it's not symmetrical anymore. Now, if I go back to symmetrical editing, the corresponding vertex on the opposite side does not move anymore. With vertices still having a symmetrical counterpart, however, symmetrical editing also still works. It can be even more devilish. Assume in the heat of the moment you move the whole mesh in edit mode, while you actually should have done this in object mode. See where the origin point is? It's still in the center of the scene where it was before. And yes, this makes the whole object asymmetric without you even noticing it. Nothing works anymore and you're scratching your head, while you could have avoided that by simply using the object mode to move the whole object. See, after moving the sphere in the object mode, the origin point is not at the world's origin anymore. This preserves the ability to still symmetrically edit our object. However, if it happens anyways, you are not totally screwed because if the object is still symmetrical, you can set the origin point to the center of the geometry. Just bring up the origin menu and select Origin to Geometry and you're done. The origin point hops to the center of the object, which makes it symmetrical again. But the gods of 3D strike back if your object is intrinsically not symmetrical anymore, which I fake here. Blender still finds the center of the object, no question, but the symmetry shifts so that the new origin point is anything else but the point of symmetry. Now you're really screwed. You think? No, still no checkmate because you can find the center of the remaining symmetrical points by selecting them, or at least 2 of them. And then select Origin to Selected in the Origin menu, which will move the origin to the center of symmetry for the remaining symmetrical vertices. And then you're back in business. But, well, yeah, if I think that the origin point now is only at the symmetry of 2 instead of 3 axes, and the origin point can also have its own local coordinate system, my adrenaline glands start itching. Speaking of the origin point, I think it's not wisely set in my object either. As you will see later on, I will import this into DAZ Studio, and there the object will be placed also in the center of the scene. If my origin is in the middle of the object, it will extend below DAZ Studio's ground plane. But what have I learned while talking about symmetry? I can move just the geometry and leave the origin where it is. Everything selected, snap on. Move, 1, 2, OK, grab the Z arrow, move, 1, and done. Nope, not done, that was too far, so 1 back, and now done. I can save it out as OBJ file by selecting File, Export, Wavefront OBJ. In the File dialog, I navigate to my Assets folder I created specifically before I started working on the ramp. See how full it already is with my previous attempts? I name it Skating Ramp 3-0 because this is the 3rd version of the ramp and the original shape. What that means we will also see later on. As I found out in one of my previous videos, the scaling factor between DAZ Studio and Blender is 100. So if I export it 100 times scaled, I can import it in DAZ Studio with the default settings. The other options in the dialog I leave at default. here as well. I hit Export OBJ and the object gets exported in no time, since this is only a tiny file, as simple as it is. Before I head over to DAZ Studio, I want to mention an alternative way of creating symmetry, because that one also triggered me scratching my head. As you can see, I'm about recreating the model, but this time I stop after the first wedge, because here the ways part. Instead of using symmetrical editing, I go for a mirror modifier. Modifiers in Blender are a non-destructive way to modify a mesh. It's kind of an instruction which effect Blender shows only, without changing anything in the mesh unless the modifier is applied. They have their own panel where you can stack them up, because you can set up multiple of them. I'm in object mode, by the way. I click on Add Modifier and get an extensive list of various modifiers. Here I decide for the mirror modifier. By default it mirrors the x-axis, that's the red one. Here of course nothing happens because it's already symmetrical in that axis. Like before, my point of symmetry is the object's origin. If I switch the modifier's axis to y, I see the mirrored shape as well. The modifier actively mirrors the geometry. Whatever the original geometry looks like, the mirrored copy will follow. And that's the case until it gets applied. But it wouldn't be me not falling for the next caveat. For what I want to show you, it's better to hide the modifier's output, and I can do that with a little screen icon in the modifier setup panel. Now, I guess you will agree that the cube has 8 vertices, 7 of which we see 1 is hidden. And that leaves the 4 vertices for the face at the tip of the wedge. Makes 12, doesn't it? 12, see, 2 are selected by the way. That does not change even if I unhide the modifier. It's not applied yet, so we only have the original geometry, which consists of 12 vertices. Now I change to the object mode and apply the modifier. The modifier is gone, and if I switch back to the edit mode, I see the vertices of the new geometry. With the 4 new vertices, I'd expect my object to have 16 vertices now. But it's 24 now, with 4 selected, that's the selected face at the tip. Why the heck is this? Well, the mirror modifier did exactly what it is supposed to do, create a mirrored copy of my object. So if there were 12 vertices before the operation, there are of course now 24. They were just placed so exactly that they perfectly align, therefore I can't see them as 2 verts. If I box select seemingly 1 vertex, it's actually 2 selected. This puzzles me because the modifier, which I restored here with a couple of undos, offers this merge function, which is on by default. This claims to automatically merge vertices to only 1 if they come close to each other, so obviously this does not work as intended. But after a brief investigation, it's obvious that it works as intended, just Blender's intention is different than mine. Here I have a simple cube and the mirror modifier is already on. I can move the cube smoothly and the modifier creates a mirrored ghost. Note that the merge distance is very small, but if I increase it, you will see that the smooth ghost behaves differently. Just watch the ghost's left face. Once it comes close to the right face of the original mesh, it suddenly jumps to congruence with the original. Then it sticks to it until the merge distance is exceeded and it gets released. The effect gets even more pronounced if I double the merge distance. The reason for that behavior is that the modifier's merge function only gets applied to the vertex and its mirror, not to the whole mesh. In other words, these two will be merged because they are siblings. These two can come close because they are different families. So does that mean I can't use the mirror modifier? No, because there is another merge function. In the edit mode, I select the whole mesh and then I go for Mesh Merge by Distance. Then a little settings panel pops up in the left bottom of the viewport. which I can expand and which allows me to set the merge distance. Down in the status bar, Blender tells me that 8 vertices have been merged. I can even click this and get a protocol of what Blender did. Here I also see the distances. If I increase the distance too much, it affects the shape of my mesh itself, and that's not what I want. Before I import my new object, I want to prepare you and the scene for the next steps. DAZ Studio also has some primitives, and for demonstration purposes I load a plane and a cube. Both cube and plane have vertices spanning faces, and each face has a surface. The surfaces have a material which tells the shader how to render the model. Currently I'm in the OpenGL preview. This is a very primitive way to show you how the objects look like, but when I switch to the iRay preview, my objects get ray traced. Ray tracing is an algorithm that follows the light from our eyes through a projection plane to the scene we observe and on until it is at a light source. It is said that the technique goes back even to Albrecht Dürer. Although Dürer might have used it for getting the proportions in perspective right rather than using it for finding the proper lighting. Anyways, I only have to change the viewport's draw style options to iRay and I can adore the ray traced preview. What I get is, well, not that great, but yeah, that's how a white matte cube looks on a white matte plane in the sunlight. To make it look like something, I apply shaders. With the plane selected in the scene graph, I open up the Surfaces pane. By default, I land in the Editor tab, where I can tweak all the parameters and settings the shader offers. Notice that the plane is also selected here in the Surfaces pane. The changes I make apply to all surfaces of the plane. If I switch over to the Presets tab, DAZ Studio will show me suitable presets for this asset. Since I have a ton of assets installed, this takes a while, but I can uncheck Filter by Context, and Studio will show all presets. The presets are organized in categories, because the assets' locations are defined by the creators, who often have a different idea where the assets should go. The default categories get crappier the more presets you have, so I created my own custom ones. Once I found the right category, the Surfaces pane would show me all the shader presets I put in there. In this case, I go for tiles. If I double-click a preset, all the shader parameters and settings get loaded and the viewport follows immediately. Concerning the cube, I decide for a really ugly-looking deteriorated paint on metal. If you have the shader presets ready, DAZ Studio offers indeed a very simple way to give your objects an interesting look. But that convenience ends if your objects are not well prepared, as we will see. I import the model of my ramp by selecting File, Import and my OBJ file in the File dialog. In the OBJ Import Options dialog, I leave everything at default. I select the model in the scene graph, apply the same shader I did with the cube, and I get this. Contortions like this usually are caused by missing or faulty UV maps. Remember how I created the ramp in Blender? I started with the cube I took from Blender's primitives. The primitives are already unwrapped, therefore the cube portion of the ramp looks okay, but the two wedges I extruded afterwards, so the UV map is not unwrapped there. Because DAZ Studio doesn't offer UV tools, I gotta fix this in Blender. Blender offers different workspaces, one of which is UV editing. On the left side, I see the 2D view of the UV map. The right side is used for selecting entities in the meshes. If I select everything in the right side, I can see the corresponding UV map, in this case the typical net of polyhedrons of a cube. This observation supports my assumption that only the cube is unwrapped so far. In the right window's header area, I can go to UV, Unwrap and see what Blender can do automatically. Nothing so far. But I've got a warning message. Unwrap failed to solve one-of-one island. Edge seams may need to be added. Thank you. Then let's do this. Let's add seams. The reason for Blender needing seams is that the mesh I created is closed. That means Blender has to know where to tear it apart. The seam is probably best at the bottom of the object. So I select the edges running around the bottom faces. When I'm sure I've caught all edges, I go to UV, Mark Seam. Blender marks the edges with a red overlay, telling me that at this seam the mesh will be torn apart when unwrapping. Now I select everything and hit Unwrap again. This time I get a completely different shape in the 2D window. Blender created two islands. One is the bottom of the model and the other one the top. It also didn't find the perfect shape, so that I can't get away without further tweaking. In the next step I use a Blender add-on called UV Toolkit. I need it only for convenience. You can do also without. It's just more time consuming. I add a grid map so that I can see how evenly the texture spreads over the mesh. Here I find the texture on the cube distorted. I can grab a vertex on the UV map and move it around, but note that on the right side only the texture moves. The vertex on my mesh stays where it is. With that I can try to even out the distortions. There are functions for automatically straighten the UV. And I can do everything to mitigate the problem, but I won't get entirely rid of it because triangle shapes do not go well with the rectangular nature of the cube. In my case, I do not have to go crazy about the quality of the map, because I just intend to put on some paint, no tiles where any distortion would stick out like a lighthouse. I also don't care about the overlap of my two islands. That could be a problem if I were to provide an image that wraps over the model, then you would see the overlapping portion twice. Anyways, it's not a big deal to correct that. Finally, I save it out as OBJ file and I name it skatingramp3-0-UV to make it clear that it's the same file but just with a different UV map on it. Also, I double check that export UV map is on. In DAZ Studio, I do not have to import the whole object again. There is a function to only grab the UV map from the file. With the object selected in the Scene Graph, I open up the Scene Graphs menu. There I select Edit, Geometry, Load UV Set. In the File dialog, I go for the newly created OBJ file. Be aware that this only works if the geometry is the same. If it suddenly has more or less vertices, Studio can't assign the map. I have to enter a name for the UV set, since an object in DAZ Studio can have multiple different UV maps. I type in UV-01 and hit OK. Nothing happens in the first place because I just loaded the map. I have to select it, since there are two maps for this object now. In the Surfaces pane, I switch to the Edit tab and select the model's only surface. I navigate to the Geometry selection of the shader's properties, and there I find a setting for the UV set showing me the available sets. I select UV-01 and the texturing is fixed. Yes, I know, it still looks a bit bent, but I can cheat by playing with the tiling. In the Geometry section of the shader properties, I select tiling, so I only see these parameters. I can change the number of tiles, that is the number of repetitions within the UV space, and the offset of the UV map on the mesh. Rotating the texture is not possible within DAZ Studio. I can either do this by creating another UV map or editing the images before loading. The iRay preview reveals another detail I'm not happy with. Look at the edges. They are razor sharp and do not look natural. This is not specific to my ramp model. Also, the cube in the background suffers the same flaw. This is because in nature, edges usually are not sharp like that. They are always rounded, and even it might be a tiny radius, it will make a difference. You will see. Adding chamfers or bevels is an essential technique in hard surface modeling, and Blender supports us by providing a modifier for that. Like we saw it before, I open up the Modifier panel. This time I select the Bevel modifier. Similar to the other modifiers, this one starts to work immediately, and I see that my model now has a chamfer on all outer edges. This will become even more obvious if I switch off the shading. By default, the modifier produced a simple 45-degree chamfer, but I can crank up the number of faces on the bevel. The more faces I dial in, the smoother the appearance of the object is. But that comes with a price. Once I apply the modifier, Blender will generate real geometry with real vertices. Considering the bevel runs around my whole object and I have also complicated crossings, I'll end up with many vertices and faces. Therefore, I decide for a compromise. 96 words are not that bad actually, and the light has some odd angled faces to get scattered into different directions. So I have new geometry and ask myself, what happened to the UV mapping? Nothing so far because the modifier has not been applied yet, therefore the bevel is not part of the mesh. So I must apply it first. In my little excursion to the mirror modifiers, I learned that there is that puny little drop-down menu in the modifiers panel. But if I go for apply, Blender bites back with an error message. That is because modifiers are a thing in the object mode, so they can only be applied there. I change to the object mode and now it works. The modifier is gone, but still no effect. Okay, back in edit mode I must select everything, and on the left side I see pretty much the same net like before. So Blender obviously adds the additional geometry to the existing in a way that the UV map does not get destroyed. Okay, better not look too close, shall we? But yeah, that's a tiny imperfection and I wonder if it's worth spending any more time with it now. If I see there's trouble with the shader, I'll fix it later. I always can load a new UV set, remember? The export procedure you know already. Don't be fooled that in the background my modifier's back. This is a screen cap of my original attempt. I recorded the check of the UV map afterwards. But it also reminds me to mention that by default Blender applies all modifier on export. I don't have to click them individually. In my homebrew naming system I call it now Skating Ramp 3-A, and I don't forget to set the scaling to 100 times. In DAZ Studio I move the unbeveled version out of the way first. Then I import the version A of the ramp. Look, even on the untextured preview you can see the bevel clearly. And finally I apply the same texture like on the original object. And the IRE preview confirms it looks so much nicer with a bevel. Notice those glistening edge reflections here? You simply don't get them with just sharp edges. Also the texture really looks wrapped around, not just pasted on each face. In the beginning I promised a morphing asset. This is just a dump model, no morphs, not yet. Before I go on, I delete the props I don't need and head over to Blender again. The idea of a morphing asset is making changes to the original shape of my object and load these changes as deltas into DAZ Studio. That means if for example I want to squash the ramp to only a fraction of its height, I do it here in Blender rather than just height scale it in DAZ Studio. Because I'm using a modifier for the bevel, I do not even have to care about the many vertices and faces of the bevel to be squashed as well. They keep their proportions because the modifier is applied afterwards. It sees the shape as if I created it like that in the first place. Well, at least that's the theory. If I look carefully, I notice that a bevel is missing. Okay, I don't need it in this place anymore. Lowering the top face also changed the wedge's angle, so this is no sharp edge anyways. The modifier does not consider this to be an edge worth a bevel. Why this is a problem? Well, just think of it. If DAZ Studio wants to create a list of delta positions between the two models, what is it supposed to do to the vertices which are not existing anymore? No, the model must have exactly the same number of vertices, edges and faces. Even the order of the vertices must be the same, otherwise it won't work. Luckily the modifier has a setting that helps. If I reduce the minimum angle there, the bevel magically comes back. Now all I have to do is to export it as OBJ using the same settings I had when I exported the original, and then import it as a morph in DAZ Studio. As for my naming scheme, now I call it Skating Ramp 3-B. In DAZ Studio I make sure the ramp object, it's called prop there, is selected, and then I open up the Scene Panes menu. There I go to Assets, Morph Loader Pro. This brings up a dialog containing some familiar settings. Because I'm importing data from an OBJ file, I can set up the scaling and axis conversion. Here I just make sure I use the same settings like in my initial import of the model. Finally, I select my morph files. This time it is skating ramp 3-B. After I confirmed my selection in the file dialog, it shows up in the morph loader where I hit accept. And this is the message I've been waiting for. DAZ Studio could create the morph. If I now switch to the parameters pane and I select the prop there, I will find a new slider named like the loaded morphed OBJ file, in my case skating ramp-B. If I move the slider, my object smoothly morphs from shape A to shape B. And because it has to do the calculations in between the two shapes anyways, I can also extrapolate and make the prop bigger than intended as well. If I made a mistake in Blender, for instance forgetting that my Bevel modifier caused bevels to be cancelled, I get the dreaded geometry did not match error. Then I must go and find where's the differences and what caused them. And there is another behavior which is important to bear in mind. The morph interpolation is linear. If you plan to do something like this, don't expect the morph follow exactly the same transition. It may look like a rotation, but it's not. All the vertices follow a linear path which causes the object to scale in size during the transition. It can get even worse. A 180-degree rotation results in quite a chaotic shape if I'm halfway in. In one of my previous videos I rigged a bicycle. The rotation of the fork would not be possible using the method explained here. It requires a rigging. If you are interested in that, you might consider to watch that video as well. No worries, it also has chapters. My asset still has a flaw for which I found only a wonky fix. See the textures on the side? If I reduce the height, they get squashed. So far I only found a mitigation for that problem, not an elegant fix. In Blender I correct the UV mapping. I do this on the unbeveled shape because I already know it will fit the beveled version as well. I save it over the B version of the model and load this version's UV data in DAZ Studio. Now I can easily switch the sets according to my needs. Because I learned how it works, I create two other morphs as well. Morphs can be combined and Studio will add the deltas sequentially. So in addition to the width morph, I can also flatten the ramp with my other morph. And I can provide even more UV maps to also fit this shape. If I do not want to mess around with many different UV sets, I can also split off the surfaces on the side and gain individual control over the tiling parameters for that selection. I activate the Geometry Editor tool and drag select the three faces on the front. Then I expand the selection by one additional face in each direction by bringing up the Viewport's context menu and select Geometry Selection, Grow Selection once. This will set the split seam of my surface to somewhere within the bevel. Now I go for the context menu again and choose Geometry Assignment, Create Surface from Selected. In the subsequent dialog, I elaborately name the new surface Side. Then I turn to the back of the ramp, repeat the selection, grow it, and assign it. But this time I have my surface already, so I decide for Assign to Surface and select Side, the newly created item. Next I have to copy the shader settings to the new material, which I can do in the Surfaces pane. There I select the existing shader. That's the one with the incredibly long name Blender's UV toolkit came up with, and I didn't bother to change. I hit Ctrl+C, select the new surface and paste the settings with Ctrl+V. Please note that this only works that way if the shader models are the same. The deteriorated material is an Uber shader, the blank default as well. It has the same parameters, hence it works. In the tiling section, I can set the appropriate scaling factor on the right axis. Now I have an even more flexible asset. If I flatten it, I can adjust the tiling factor. But this also comes with a price. See how the textures of the two surfaces are not aligned? It doesn't wrap around but breaks. I have to correct that manually. That can be tedious and doesn't always pay off. Eventually you might ask, why go for this effort and create a morphing prop? Well, I'll show you one example. Recently I needed a bunch of skaters for one of my ongoing projects. Creating a sitting pose like this is always some work to do. Not only that it might be hard to find a natural looking posture, also you have to define the points where the body gets in contact with the environment. Now, what if instead of our adolescent skater, I want to depict his little brother? In order not to start over with posing from scratch, I reuse the pose I already have. I save out the pose of the older kid and apply it to the younger. That goes in an instant, but because I never saved the figure's location with the pose, I now must place the younger brother's figure. For this, I'm in the OpenGL viewport rendering mode because Iray would be too slow. OpenGL sometimes appears very dark, but later versions of DAZ Studio offer another renderer called Filament. Filament renders much brighter, what some people find annoying, but for me it's good because I can see the contact areas better. I place the figure in a way that the feet touch the ground, since I know that I can adjust the ramp he's sitting on. If someone is in close contact with an object, sitting, leaning, grabbing, etc., I tend to use mesh smoothing. For this, I add a smoothing modifier. I select the figure, open the Scene Graphs menu, and select Edit, Geometry, Add Smoothing Modifier. In the Parameters pane, I find a couple of new elements, one of which is the Smoothing Iteration slider. Here I can set how smooth the mesh will be. But I need to be careful. If I overdo it, all details of the mesh get lost. So what's that good for? It helps with contact areas. Here I created a cube, and I can set this cube as a collision item for my figure. If I now move the cube to the nose, the tip gets flattened. Just a bit, but it's a cool effect, which saves a lot of time. If I make it out of glass, he's flattening his nose on a window. What a nosy lad. The mesh collision detection helps only with small overlaps, but here it is massive. I can either repose my figure, it will take a couple of minutes, or use the morph on my new asset. That's cheating, but who cares if you don't notice it? It only took me 2 seconds. Done. And I think that's it for this video. Hope you enjoyed it and see you in the next one.